You weigh less than a raindrop. Your entire body is shorter than a fingernail. Right now, thousands of your sisters are moving around you in total darkness, and somehow, none of you are confused. This is what it is like to be an ant. Not a queen. Not a soldier. Just one of the workers, one of millions, born to a job you never chose and will never question. For roughly 140 million years, ants have been running colonies more organized than most human cities. Some colonies contain over 20 million individuals. So how does something with a brain smaller than a grain of rice help build something that's smart? Let's start with your senses, because they are almost nothing like ours. You don't really see the world. Your eyes are compound, made of dozens of tiny lenses, and they mostly detect motion and light, not detail. You don't hear in any way we'd recognize either. Instead, you feel vibrations through the ground, through your legs, through tiny hairs covering your body. But your real language, the one that runs your entire life, is smell. You communicate almost entirely through pheromones, chemical signals released from glands in your abdomen. When you find food, you lay down an invisible scent trail on your way back to the nest. Every sister who crosses that trail follows it automatically, and if enough ants use the same path, the scent gets stronger, pulling in even more ants. This is called positive feedback, and it's the same basic principle that makes a rumor spread faster the more people repeat it. Biologist E.O. Wilson spent much of his career studying exactly this. Wilson, working alongside Bert Holdobler, documented how ant colonies use chemical communication to coordinate work without any single ant knowing the whole plan. Nobody is in charge of the trail. Nobody designed it. It just emerges, ant by ant, one pheromone deposit at a time. Is that unsettling? A system with no manager, no blueprint, and no ant in control, somehow building something as complex as a highway network? Now imagine your job for the day. You wake up, though ants don't sleep the way humans do, they take dozens of tiny rests throughout the day and night. Your task might be foraging, nursing larvae, or digging tunnels. Ant colonies divide labor by age. Young workers usually stay inside, caring for the queen's eggs and larvae. Older workers take on riskier jobs outside the nest, like foraging, where predators and death are far more likely. This is called age polytheism, and it means your entire life is a slow migration from safe indoor work to dangerous outdoor work. The colony essentially spends its newest, most valuable workers last, keeping them protected until they've had time to learn the ropes. Ecologist Deborah Gordon, who has studied harvester ant colonies in the Arizona desert for decades, discovered something surprising about this system. Ants don't get instructions from the queen. The queen isn't a boss. She's essentially an egg-laying machine, and colony-wide decisions, like how many ants should forage today, emerge from thousands of brief antennae touches between workers. Gordon's research showed that the rate at which ants bump into each other actually determines how many ants get assigned to a task, almost like a decentralized voting system made of touch. So picture your actual morning. You leave the nest through a tunnel barely wider than your body. Above ground, the world is enormous and violent. A single raindrop could kill you. A bird could swallow 10,000 of your sisters in one afternoon. And yet you walk out anyway, following the scent trail, because the colony's survival depends on food arriving, and you are, quite literally, expendable in exchange for the colony as a whole. You find something, a dead beetle, 10 times your size. You can't carry it alone. So you release a stronger recruitment pheromone, and within minutes, dozens of sisters arrive to help. Together, you lift and drag something that would be like a human hauling a loaded delivery truck using only teamwork and no equipment. Leafcutter ants, a close relative of yours, take this even further. Field studies in the Amazon rainforest have documented leafcutter ants carrying leaf fragments many times their own body weight back to underground fungus farms, where the ants actually cultivate fungus as food, a form of agriculture that predates human farming by tens of millions of years. Here's the counterintuitive twist. You'd expect the queen to be the most important ant in the colony. She's the one who lays every single egg, sometimes thousands per day. But if the queen dies, the colony doesn't collapse immediately. Worker ants keep functioning, keep foraging, keep defending the nest, sometimes for months, running purely on inherited instinct and existing pheromone trails. The real intelligence of the colony was never in one individual. It was distributed, spread across thousands of tiny brains working on simple, local rules. This idea, that complex group behavior can emerge without centralized control, is called swarm intelligence, and it's inspired real-world engineering. Researchers have used ant foraging models to help design more efficient computer networks and delivery routes, because ants had already solved the problem of finding the shortest path between 2 points using nothing but trial, error, and chemical trails. Now think about the danger you face every single day as a worker ant. Rival colonies exist just meters away, and ant warfare is brutal and constant. Some species send scouting parties specifically to locate and destroy neighboring colonies. Others, like certain slave-making ant species documented by researchers studying ant social parasitism, raid neighboring nests and steal their pupae, raising the stolen ants as forced laborers. Your entire existence, from the moment you emerge from your pupal case, is shaped by decisions made not by you, but by chemistry, temperature, and the needs of a superorganism you'll never fully understand. And yet, somehow, this leaderless, brainless by human standards system works. It's outlasted ice ages. It's colonized every continent except Antarctica. Ant biomass on Earth is estimated to rival or exceed that of all wild birds and mammals combined. So what does any of this have to do with you, watching this right now, safely far larger than any ant? Maybe it's this. You live inside systems too, ones you didn't design and rarely see the full shape of. Traffic patterns. Social trends. The internet itself, an invisible network of pathways strengthened by however many people travel down them. You, like an ant, are often just one small signal in a much larger pattern, contributing without seeing the whole picture, and yet somehow, the whole thing keeps functioning. You weigh less than a raindrop. Your entire body is shorter than a fingernail. But right now, thousands of sisters just like you are quietly building something far bigger than any one of you could ever understand, and somehow, none of you are confused.